Okay, so in this video what we're going to do is we're going to try and find the equation of a line. And you can see here what we have in the purple bit or the pink bit here. It says the formula for equation of a line. Again, this is from Junior Cert, lads. If the line contains a point and has a slope m, then the equation of the line is equal to y minus y1 is equal to mx minus x1. We've done this before. It shouldn't be too difficult. It's just a case of working out what the slope is and using any point on the line in order to find the equation of the line. Okay. Remember from previous video, what we know is that we can calculate the slope if we are given 2 points. We can calculate the slope. That should be y2 minus y1 and x2 minus x1. We can calculate the slope using the formula there. M, the slope, is equal to y2 minus y1 over x2 minus x1, i.e. the rise over the run. So let's get straight into this and have a quick look at an example. So example 1 says the line L contains the points 5 minus 1 and B 3, 8. Find the equation of L. Okay, this shouldn't be too difficult. We've been given 2 points, so let's write them down. We've got A, and we have 5 minus 1, and we've been given B, which is 3, 8. Right, so we're going to label them x1, y1, x2, y2, and in order to find the equation of the line, we need a point and we need the gradient or the slope. Now, notice we have 2 points, so we have a point, but the one thing we don't have at the moment is the slope, so we need to find m. Fortunately, we know how to find m, because in order to find m, we can just use this equation here. So let's do that now. So we know that m is equal to, well, y2 minus y1 all over x2 minus x1. Stick in the values, we get m is equal to y2, which you can see there is 8, minus y1, which is minus 1, okay, all over x2, which is 3, minus x1, which is 5. Okay, m is equal to 8 minus 1, so that's 8 plus 1, which is 9. And then what we have then is 3 minus 5, which is minus 2, i.e. our m is equal, or our slope is equal to 9 over negative 2, or negative 9 over 2. It's the same. The next thing we need to do is we need to put it through the formula that we've just been discussing. The y minus y1 is equal to mx minus x1. And because I've labelled this x1, y1, I'm going to use the point A, just so that there's no confusion. If I wanted to, I could use the point B. It makes no difference. It's entirely up to you. So I'm just going to put a line divider here. So what we now know is that y minus y1 is equal to mx minus x1. And I'm just going to put the numbers in. So y minus, well, my y1 is here, which is minus 1. So we've got y minus, again, minus 1 is equal to m, which we've just worked out to be 9 over negative 2, all over, sorry, multiplied by x, which is just x, and we've got minus x1 here. The x1 is 5. Okay, just tidy up a little bit. I get y plus 1 is equal to 9 over minus 2 by x minus 5. Now it's easier here, guys, to multiply everything by this fractional bit on the bottom. You don't have to. It's just easy to do so. So I'm going to multiply everything by minus 2. If I do that, what's going to happen is I'm going to get minus 2 multiplied by y plus 1 is equal to 9x minus 5 on the right hand side, which means getting the bracket out, minus 2 times y is minus 2y, minus 2 times 1 is minus 2 is equal to 9x minus 45. Now, I can either put this of the form y is equal to mx plus c, or I can put it of the form all on one side is equal to 0. So I'm going to do the latter one there. I'm going to say I want everything equal to 0, and I'm going to try and keep the x's positive. So what I'm going to do is I'm going to take this and put it over to this side, so I've got 0 on the left hand side. So I'm going to do that right now. So I'm going to have 0 is equal to, okay, well, the 9x here is just going to be 9x. I've got minus 2y here, so I'm going to plus 2y. and I'm going to get rid of that minus 2 by doing the opposite, which is plus 2, and minus 45 plus 2 is minus 43. And I now have it of the form 0 is equal to something on the right hand side there. Now, convention for mathematics is that we try and keep whatever the value in front or the coefficient in front of the x, we try and keep that positive. You won't be marked down though if you don't. Okay, let's have a look at the second part of this particular question. It says the line K contains the point A and is perpendicular to L. Find the equation of K. So let's just go through that just slowly. So K contains the point A, which is great, so we know that A is on it. It's perpendicular to L. Okay, well, if it's perpendicular to L, then we know that M1 times M2 is equal to negative 1. So this is important. The perpendicular point bit of this problem is important. And then we've got to find the equation of K. So for perpendicular, we did this in a previous video. So for perpendicular, M1 multiplied by M2 must be equal to negative 1. Okay, well we have M1, got 9 over minus 2. That comes from over here, because that was the line or the gradient of L. And we're trying to find out the gradient now of K. So times by M2, that's something we don't know, is equal to minus 1. And we're going to solve. So we're going to multiply everything by minus 2, which means we get 9 times M2 is equal to, well, minus 1 times minus 2 is 2. And that means that M2 is equal to 2 divided by 9, because we have to divide both sides by 9 to get rid of this 9 times. So 2 divided by 9. From there, we're told that A is on the line. We have the gradient, so we're going to do exactly what we did a second ago in order to solve this particular part of the question. So again, we know that y minus y1 is equal to mx minus x1, and our y minus, well, it's the same coordinate as before, so it's going to be y plus 1, because minus minus 1 is plus 1, is equal to m, which is 2/9, and we've got x and minus 5. Okay, those values there come from here and here. Remember, y minus minus 1 gives us plus 1. Again, what I'm going to do is I'm going to multiply by the fraction just to make life a bit easier. So I get 9y plus 1 is equal to 2x minus 5. And from there, 9y plus 9 is equal to 2x minus 10. As I said to you a second ago, or a couple of minutes ago I should say, I'm trying to keep the x's positive if at all possible. So what I want to do is I want to get all of this on that side. So I'm going to do that now. I've got 2x. I need to get rid of this plus 9y, so it's minus 9y. I need to get rid of this plus 9, and minus 10 minus 9 is minus 19, and that's equal to 0. And I now have my second equation. So we've already discussed that there's two different ways of writing the equation of the line once we've finished up in a previous video. So we can either write it of the form y is equal to mx plus c, or we can write it of the form ax plus by plus c is equal to 0. Doesn't make any difference normally. However, when we come to do a bit more manipulation of the line, for example working out perpendicular distances to points, etc., this is actually much more useful to us than this form. So the next thing we need to be able to do with the line is to show that perhaps a point lies on the line. So for example, does the point 1, 2 lie on the line y is equal to 2x plus 3? Now, there's a very straightforward way in order to work out whether this point here, I'll call it A, this point A lies on the line y is equal to 2x plus 3. And all we do is we just substitute in our x value and our y value here into this equation or the line. So let's just do that now. We can see that for my y value here is 2 is equal to, and we have 2 by 1, so 2 by 1 plus 3. I'm just going to go up here slightly, and you can see if I just simplify that, I get 2 is equal to, on the left hand side, and 2 times 1 is 2 plus 3, and if I simplify that again, I get 2 is equal to 5. Now, yeah, that's nonsense. 2 cannot be equal to 5, so if the left hand side is not equal to the right hand side, then not on line. So the coordinate given is not on line, and if the left hand side is equal to the right hand side, then the point is on the line. So those are the two sort of ideas there. So if we're trying to prove this, there's a point that's on the line, all we do is we take the point, we put it into the equation of the line, and if the left hand side equals the right hand side, then the point given is on the line. If it doesn't, it's not on the line. So using that bit of information there, we're going to try and solve this example here. It says if the point minus 2k belongs to the line, belongs is just another way of saying is on the line, 7x plus 3y minus 1 is equal to 0, find the value of k. So here it's important to notice we're told that it does belong to the line, so the left hand side must equal the right hand side in this case. And now that we know this, it means that we can set up an equation and solve it. So again, I'm just going to label. You can see here that this is my x coordinate, this is my y coordinate. Okay, and we're going to write out 7x plus 3y minus 1 is equal to 0. That's the equation of the line. And what we're going to do now is we're going to replace the x value with minus 2 and the y value with k. So we get 7 by minus 2 plus 3. My y value in this one is k. Minus 1 is equal to 0. Now we know that these have to equate because we're told it's on the line. So the left hand side has to equal the right hand side. So it means we can solve this now. So 7 times minus 2 is minus 14 plus 3k minus 1 is equal to 0. That means we have 3k minus 15 is equal to 0 because minus 14 minus 1 is minus 15. And we're going to take that 15 across to the other side, so we have to do the opposite. So that's 3k is now equal to positive 15 on the right hand side. And solving 3k is equal to 15, we divide both sides by 3 and we get k is equal to 5. Okay, so the next thing we could be asked to do is to plot a line. So how do we do that? Well, if you think about it, this isn't that difficult. Again, we've done it in junior cert. So to plot a line, we need 2 coordinates. So to plot a line, we need 2 coordinates. Okay, not a bother. So we can see we're going to do this with example 3. We've got 3x plus 2y is equal to 9. So the best way to do is to set your x value equal to 0. And that will then give you a y value. So let's do that. So we've got 3 times 0 plus 2 by y is equal to 9. So we're going to solve for y here. Okay, so we've got 2y essentially because 3 times 0 is 0. We've got 2y is equal to 9 and y is equal to 9 over 2, which is 4.5. So that means we have a coordinate because our x value is 0. So our first coordinate is 0 and 4.5. Okay, we need to find another coordinate. So in order to do that, we're going to set, so that's the first one. Next one we're going to set the y value equal to 0. And if I do that, I get 3x plus 2 by 0, because my y is now equal to 0, and that's equal to 9, and 2 times 0 is obviously 0. So we get 3x is equal to 9, and x is equal to 3. Now, if we put that as a coordinate, my x coordinate is 3, and my y value, remember we chose the y value to be equal to 0. So I now have 2 coordinates, and I need to plot the line. So I'm just going to sketch it. You can do this a lot better than I can. So there is my axes, and I'm just going to go 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and I'm going to plot those 2 values. So the first one is 0, so here we are, 0 and 4.5, so 0 in the x direction, 1, 2, 3, 4.5, so 4.5 is roughly there, and then I'm going to plot the other one, which is 1, 2, so it's 3, 0, which is there. Then all I'm going to do is join the two together, and obviously you'd use a ruler for this, and carry straight through, and you can see there I have a wonderful straight line. So quite often what we'll need to find in maths is where two lines intersect. Now, there's two different ways we can do this. The first one is to draw yourself a graph, and then what you could do is you could draw the first line. So just in the slides before, what we can do is find the equation of the first line, and we can draw it. So for example, there's the first one, and then what we could do is find the equation of the second line, and we could draw that as well, and wherever the two lines intersect, then we can read off the graph. For example, this could be the coordinate 3, 1. Okay, so that's one way that we could work out the intersection of two lines. Now, that's all well and good if the numbers are integers, because that makes it fairly straightforward, and graphing and reading off the graph isn't too difficult. The problem arises when they aren't integers and we're trying to find exact values. And the second way we can do that is just by solving using simultaneous equations. Now, we know how to do that. I'm not going to go through an example of that, but generally what we have is a very straightforward and easy process in order to find the x and the y coordinates. The last thing this video is going to do is to just talk about equations of parallel and perpendicular lines. And you can see here that just a little bit of info in the pink box again, where you can see for parallel lines, a line parallel to 3x plus 2y is equal to 7 has the equation of the form 3x plus 2y is equal to some constant. Because if you think about it, remember that if I rearrange this slightly for you, so this would be exactly the same as 3x plus 2y minus 7 is equal to 0, and our gradient m is equal to minus a, which in this case is 3 over b, which is 2. So as long as all of the gradients are of the form minus 3 over 2, then they'll all be parallel. Well, that just means that the x's and y's have to be the same. So it's fairly straightforward. If you have your same x's and y's in the equation, when it's of the form ax plus by is equal to c, then they will be parallel. Now, if we're trying to find all of the perpendicular to the line of 3x plus 2y is equal to k, that means that my m here of the 3x plus 2y is equal to k is minus 3 over 2. So for the perpendicular, that means that, as we said before, m1 times m2 must be equal to negative 1, which means we have minus 3 over 2 times by m2 is equal to negative 1, and solving that you get m2 is equal to 2 over 3. So that means that what we have here is 2/3 is what's going to be for my perpendicular line. Now there's a nice easy way in order to solve this. You don't have to worry too much about that. What you have is, suppose I have 3x plus 2y, try again, 3x plus 2y is equal to k. In order to find the perpendicular, what I do is I switch the x and the y values round, and I change the sign of one of them. So I'm going to switch them around, so now I've got 2x, plus 3y, is equal to some constant, doesn't matter what it is, 7 will do, any constant. And what I'm going to do is I'm going to change any one of those. I'm going to change this one because it's easier. And you can work out yourself if you wish, if you work out the gradient of this now, the k is not really going to affect it. So let's go to the side, we'll do it together. If I work out the gradient, so I've got m is equal to minus a, so it's minus 2 over b, which is 3. So m is equal to 2/3, which is what we said it would be earlier on in the video. Now we'll just go quickly through this example 5. This shouldn't be too difficult. It says find the equation of the line through 2 minus 3, which is parallel to 3x plus 4y is equal to 1, and then which is perpendicular to 3x plus 4y is equal to 1. Okay, so the first thing we need to do is we need to find out the slope of 3x plus 4y. So 3x plus 4y is equal to 1, and for the parallel, we know that m is equal to minus a over b, which is minus 3 over 4. Okay. Now, we know that this has to go through the points 2, minus 3, so we have all the information that we need to use y minus y1 is equal to mx minus x1. Okay, so we know that y just stays as y minus y1. I'll just come up and label them. So this is my x, this is my y, or x1, y1. So y minus 3 becomes y plus 3 is equal to our m, which we just worked out, which is minus 3 over 4. And then what we have then is x minus the x value, which is 2. Okay, multiply everything by 4, so we get 4y plus 3 is equal to minus 3x minus 2. And then we're going to solve, well, we're going to multiply out the brackets, sorry, so we get 4y plus 12 is equal to minus 3x. And minus 3 times minus 2 is plus 6. Just make sure you don't fall for that double negative. Right, we want everything to be, we want the x's to be positive. So what I'm going to do this time is I'm going to take this one across to this side and everything across to the left. And if I do that, what I get is I get 3x, because minus 3x, I have to do the opposite, which is plus 3x, plus 4y, and I get plus 6 is equal to 0. And that there is the equation of the line, which is parallel to 3x plus 4y is equal to 1, but goes through the coordinate of 2, negative 3. Now, for the second one, it says exactly the same sort of idea, apart from we want perpendicular. Now, hopefully, we can see if we want the perpendicular one, that if m is equal to minus 3 over 4, as it is here, then it doesn't take too much manipulation to get that our m for the perpendicular is equal to, and it's going to be flip and change the sign, so it's going to be 4/3. Okay, so if you're not sure about that, just go to the side and just have a work that out yourself. And we're going to do exactly the same thing. We're going to do y minus y1 is equal to mx minus x1, and just put the values through again. It's the same coordinates. So we've got y plus 3 again is equal to m. So the only thing that's changed from the original equation here is the actual slope. So x minus 2, and then multiply everything by 3. So we get 3y plus 3 is equal to 4x minus 2. 3y plus 9 is equal to 4x minus 8. And again, as I said to you before, we're trying to keep the x's positive, so we're going to keep everything on the right hand side this time. It doesn't matter, but just convention, maths convention says that we like to keep the x's positive. So it's going to be 4x, take away the 3y from this side here, so minus 3y, and we've got minus 8 minus another 9, which is minus 17, is equal to 0. So there we have it.